Good afternoon. This is a replacement video for the original Lecture 16 videos, which were unusable because of my defective headset. And hopefully the audio in this replacement will be a little bit better and more useful for you. First thing we did on October 15th, Lecture 16, was to go through an example of computing the pointage that comes from class participation with your iClicker, and it goes into your semester grade, 25 points out of your semester grade. So let's do an example together, and I basically used my demo student account to set up a bunch of scores that are going to be similar looking to what you have. Here's the top of the grades page. If you go down the page, you'll see a bunch of data that starts with L5 answers, and then L6 answers, L7 answers, L8.1, L8.2. That is a lecture in which Section 1 had more questions than Section 2. So no worries about that. We'll get it all sorted out in the end of the semester. Anyways, Lecture 1 has a slightly different number of questions than Section 2. All right, here is what it looks a little further down the page. You know, L9, L12, another one that has two different values for different values for each section. So L12.1, L12.2, and on down to the bottom to L15. Now that's as far as we went on Thursday, and so as of October 13th, L15, all the data at that time were in web courses. And here's an example of what a morning student could possibly have been looking at. So you look at the number of points you have under how many you have answered. So Lecture 5, this particular student answered one question. Lecture 6, this student answered once. Lecture 7, once. Lecture 8, 3 different questions. Lecture 9, 2 questions were answered. Lecture 12, 3 questions. Lecture 13, 6 questions answered. Lecture 14, 2 questions answered. And Lecture 15, 4 questions answered. Now, the participation pointage comes out from how many you answer, whether you answer correctly or not. And so this is the part of your data in the grades page that goes into your 25 points for class participation. Now the L5 correct, L6 correct, and so on, that goes into bonus points at the end of the semester if you score 75% correct at the end of the semester. I'll talk more about that in November, a few weeks. Anyways, here's what the two sections look like. Section 1, you guys have had 31 possible questions. And Section 2, 28 possible questions to answer, a few less. The way that the clicking totals work, if you answer 85% of the questions or more, then you get 25 out of 25 automatically. That is the performance criterion for class participation. So for Section 1, you had 31 possible. That means 85% if you have 27 or more. And if you do, you have 25 out of 25 for that part of your semester grade. Now, Section 2, the noon section, you guys have a few fewer questions. So for you, 85% translates to 24 questions answered or more. So if you have 24 or more, when you add up your grades page, you guys in Section 2 Bing, 25 out of 25. And the good news is that there's a huge number of you that have the 85%. So uh, for section 1, it's like 64%. Section 2, it's like 66%, something like that. Have 25 out of 25. All right, let's do a calculation. All right, so you're working on, you add up your answers. So L5 answers, L6 answers, and so on. And then you add up the total. Now that's in the second column of the grades page. That tells you, basically out of how many possible. So you add all those up. And that allows you to figure out your percentage. So if you have 85% of the total possible, then you have 25 points automatically. That's the easy one. So figure out your 85% criterion, your 85% level, and then if you add up your answers and you're above that, ding, you have 25. No further calculation necessary. Now, if you're below that level, so for instance, if you're below 27 or if you're below 24 for sections 1 and sections 2, respectively, then you have to work out the proportion. It's not that bodacious. Let's work it out. So the first thing you do is you calculate your percentage. So for the morning section student, that adds up to 23 out of 31. And that percentage is 0.742, 74.2%. Okay? So, and that's less than 85%. So this is an example of where you have to use proportionality. All right, divide that by 0.85, the leeway factor. So you take your percentage and you divide it by 0.85. So in this case, 0.742 divided by 0.85. Okay, and that is part of a proportion that you need to solve in order to figure out your 25 points. So now you take the result of that quotient and you multiply by 25, and that'll give you your points. So basically what you're doing is you're solving this proportion here, 0.742 divided by 0.78, 0.742 divided by 0.85 equals your points divided by 25. Okay, solve that, cross multiply basically, and you'll get a number of points, and it'll be a fraction, probably, 23 point something. So I always round up. All right. Now let's figure it out. This was a clicker question, and you don't have to use your clicker now, but for this particular student, he wants to figure out how many points he has right now. So you multiply you divide 0.742 by 0.85, and then you multiply by 25, and then you round up, and what you do is you get 22 points. So this particular student, 23 out of 31 clicking for the morning section, gets 22 out of 25 if I were going to give semester grades today. All right. Now, in general, here's the proportion that you have to solve. Your percentage divided by 0.85, the leeway factor, and then your points divided by 25 on the other side. So solve for your points, and you can basically do it anytime you feel like. And anytime I update the clicker pointage, yep, you can figure this out again. And so you can stay abreast of that part of your semester grade. Now, I can't ask for questions, but if you do have a question, you can post a question about clicking in discussions. And don't put in your specific points, though, because that violates the federal privacy rules. But, give a hypothetical or something, or just a general question, and that we can definitely work out. All right. Now, Um, in lecture 15, we talked about kinetic energy and free fall for a basketball. And then in homework, Wednesday night, uh, Tuesday night and Wednesday night, you were to calculate the speed of a falling basketball at a certain height. So what we're going to do is reinforce and hopefully explain for some of you that got tripped up on that, how to do that calculation. And what we did was we worked it out on the document cam. So if you were in class and took decent notes, you've got something that looks like what we're about to look at. So let's go to the doc cam and see what we got. Okay, here's the setup for the morning section. We were working with a basketball for which the basic specs are 0.600 kilograms, weight force of minus 5.88 newtons. And from that, we were trying to figure out the downward speed at 2.5 meters above the gym floor. And this image shows the table that we worked with. So let's get to the table and work out the different specs. Okay, this one, the trajectory was a straight free fall trajectory downward from rest at 3.5 meters. Now, since it's from rest, that tells you that the kinetic energy is 0 at 3.5. Okay, now to figure out the GPE, you have to calculate. Okay, that gets this little blue circle, a little blue ellipse. And that comes from the formula for GPE, which is basically 5.88 newtons times delta Y. And that's measured relative to the floor. So in this particular case, it's 5.88 times 3.5. And when you do that, you get 20.58. Now, the conservation of energy and the definition of total mechanical energy stipulates that the total mechanical energy is the sum of the gravitational potential energy and the kinetic energy. So once you have two boxes on any row, you can figure out the third box. And in this case, we can figure out that the total mechanical energy by conservation of energy is 20.58. All right, now, once you get anything in the total energy column, like this one, then you can immediately go down the column or up the column if you're down towards the bottom. And we're up towards the top, so we can immediately fill this in, 20.58. Good. I have the height or the position, the Y position in meters for this second row. It's 2.5 meters. That lets me calculate another GPE. So let's go through it again. There's the GPE calculation, conservation of energy, 20.58 in this column, 20.58 all the way down the column, including this row, and now 14.7 for your calculation. And that is GPE at the elevation 2.5 meters above the gym floor. So 5.88 times 2.5 is 14.7. All right. Now, conservation of energy means that 20.58 is equal to 14.7 plus whatever the kinetic energy is. So if you want to figure out the kinetic energy, you just subtract. So 20.58 total energy minus the GPE, and that gives you 5.88 for the kinetic energy at the elevation that you seek. So there's other ways to calculate this. I'm not saying there isn't. But if you do want to take a systematic table approach, this is one way to do it. And remember, there are certain things that you can calculate at every step, like the GPE, if you have the elevation. And there are certain ditto marks that you can put down, like the total energy column on the right. That's 20.58 all the way down as far as you need it. And then there's a bunch of simple calculations of adding or subtracting to get the other boxes that you need. Once you have that box, 5.88 joules of kinetic energy at y equals 2.5 meters, now you're ready to figure out the speed, because you know that 5.88 joules, that's equal to 1/2 mv squared, and we know what the mass is, 0.600 kilograms. So let's take a look at that. Here's our kinetic energy, 5.88. Okay, just put that into the formula, the definition of kinetic energy. Ke equals 1/2 mv squared. And then just put in the other things that you know. For instance, you know that the mass is 0.600 kilograms. You can cancel the kilograms left and right, and that leaves meters squared per second squared on the left, and a v squared unknown, that's what we want, on the right. And actually 1/2 times 0.6, that's the same as 0.30. So the second equation down, or actually the third equation down, reads 5.88 meters squared per second squared equals 0.300 times v squared. And notice that there's no kilograms on the right now. There's no kilograms on the left either. On the left, you have meters squared per second squared. That's good because you're looking for a v squared value. And you may be saying to yourself, hey, Dr. B, why did you write down 5.88 kilogram meters squared per second squared? Isn't that a joule? And the answer to that is yes. But I know that I want to cancel something, and what I'm going to try to cancel is a mass. And so if instead of writing down 5.88 joules here, and instead I write down 5.88 kilogram meters squared per second squared, I'll have kilograms on both sides, and I could chop them right out. Okay, now, as I've mentioned before, sometimes you want to use Newton meter, NM, as your energy unit, because sometimes you want to cancel out a force, or sometimes you want to cancel out a delta X or something like that. All right, if you want to do that, yeah, use NM. Now this one we want to cancel out some kilograms, and we get 5.88 meters squared per second squared equals 0.300 times v squared. Now I want to get v squared by itself, so I divide both sides by 0.300, and that gives me 19.6 meters squared per second squared on the left, and v squared by itself on the right. And now all you have to do is hit the square root key on your calculator, and you get the value of the downward speed, 4.43 meters per second. Now, in class, we did a clicker question of a hammer on the moon, and we figured out its kinetic energy and then its speed. So let's get to it. And as I mentioned here, on the moon, the strength of gravity is smaller. Matter of fact, it's 1.62 meter per second squared. And since we're doing downward stuff here and energies and so forth, let's put a minus sign on there. Negative 1.62 meters per second squared. So it's a lot smaller than the strength of gravity here on terra firma. And that is because the mass of the moon is only 0.0123 times the mass of Earth. In other words, 1.23% of Earth's mass. The radius of the moon is also smaller, 0.2725 of Earth's radius. So it's smaller, and in mass, it's smaller in radius, And if you work out all the figures, with Newton's constant and, G m1, m2 over r squared and all that stuff, you can figure out that the mass, you can figure out that the acceleration due to gravity at the surface of the moon is negative 1.62 meters per second squared. All right, we're dropping a hammer on the moon, and I just looked up a typical hammer from Stanley, and it had a mass of 0.703 kilograms. Okay, nice. So that's the one we're going to pretend that we're dropping on the moon. So the first question, basic principles. What is the weight force of this hammer on the moon? Okay, 1.62 times 0.703. And if you calculate those two numbers together, you get a weight force of 1.14 newtons negative, i.e. downward, for this hammer on the moon. Now we need that, as a basic spec, and also so we can kind of ground ourselves and maybe get ready to calculate mgy or f delta y or anything like that we want. Now the second question, using the clicker, we're almost done. The second question with the clicker was this. Okay, the astronaut drops the hammer from the small platform of the lunar module from a height of 2.2 meters above the surface of the moon. And you can see from that picture that 2.2 meters is not unrealistic. That's one of the moon astronauts on the lunar module getting ready to descend to the surface of the moon. So the question is, what is its kinetic energy? And at the height of 1.1 meters, so in other words, halfway down. Now, in this one, the calculation is similar to the homework problem we had. You're dropping it, so in other words, it doesn't start with any downward speed. So VI is equal to 0, and it acquires downward speed. You can calculate the kinetic energy, mg times negative 1.14 newtons times delta y, and delta y is negative 1.1. And when you do that, you find that the change in the kinetic energy gives you a new kinetic energy at this height of 1.253 joules approximately. And since that is 1/2 mv squared, and since you know the mass, 0.703, you can now use the same procedure as we did with the table and figure out, as many of you did, very, very many of you did, successfully on Thursday with clickers, right at the end of class, that the speed at 1.1 meter on the way down to the surface is downward 1.89 meters per second. And that is the last calculation of lecture 16. So try to review this lecture and get yourself ready for exam 2, and I will see you on Thursday. And try to be ready. Thank you.